Right, hello, it's Mr. Smith again here. I'm going to look at today for stage 6, units 4 and 5. So stage 6, units 4 and 5. There's quite a few topics I need to go through here, so let's just go see what I can do very quickly on this. The word polygon. Right, polygon is a two-dimensional. That means it's flat, like this whiteboard I'm writing on. So it's two-dimensional, flat, in other words, shape with straight sides. It must be straight. So, for example, at the moment I'm drawing a 5-sided shape. It doesn't matter what it is. It doesn't matter if it's regular, means all the sides are equal, or irregular. It's just a polygon. A polygon is generally just any two-dimensional flat shape with straight sides, and they must join up to the corners. Corners, another word for corners, vertices, yeah, and that is a polygon. If I draw that on the board here, which is trying to do a half a circle, which is a semicircle, because it's got, even though it's joining up, because it's got a curved part to it, that is not a polygon. Remember, so a polygon is a two-dimensional shape with straight sides. And we should know all our names of polygons, okay? So let's just go through them quickly. You've got these in your exercise book. Obviously, 3 sides is tri for 3, so triangle. Okay. 4 sides, quad for 4. Okay, let me just make that neater. So therefore, underline that in blue. There it is. Quad, quadrilateral, that's 4 sides. Again, there it is, underline that, keyword there is quad, and then after that, you expect to know up to 10 sides. 5 sides, like the island in Derby, it has 5 exit routes off, so it's called Pentagon Island, so Pentagon, ways of remembering it. 6 sides is hexagon, okay. 7 sides, well, I remember 7 sides is what women do in the Olympics. They do 7 events, so it's called heptathlon. So we there call that heptagon. Okay. 8 sides, well, think of the sea creature octopus has 8 legs, so octagon. 9 sides is called a nonagon. I'm just going right down to the bottom of the board. And 10, well, similar to the 7, men do 10 events in the Olympics, so it's decathlon, so we call it decagon. So they're all your names of shapes, and could be asked to, remember those or know them, yeah? There, okay. Right, moving that off there, let's just take that off. I'll leave the top bit on about the word polygon. Now, I've already said this, but if it's regular, so if you've got a regular polygon, that means all sides are equal, but not just that. It's all symmetrical around it. It's all interior angles. That's the angles inside. It's a fancy word like interior design. So all interior angles are equal, and all actually outside angles are equal, exterior, but I'm not worried about that. So that's what regular means, okay? Irregular means not that. So all sides are different, all the angles are different, yeah? So a polygon can be regular or irregular. It's just a general shape with any straight sides, two-dimensional, flat, whether they're all equal or not, doesn't matter, yeah? On that one. Just going to rub that bit off. I'll keep the word polygon on the board as my focal point to this word. Okay, special triangles. Okay, special triangles. Let's look at those. We've got, well, the most common triangle we've got is one. I'm trying to draw it here the best I can. Let's draw it a bit better than that. Let's make it a bit longer than that there. I'm trying to draw all the sides being different. Yeah, straight sides, it's a polygon, it's a triangle, and we call that scalene. That means all the sides are different lengths, all the angles inside are different as well. Then we've got the one which has 2 equal sides, and it's got 2 properties, this has. Right, when we put dashes on it, that means, we'll move out the way in a minute, that means equal sides. Just move out the way. And what it's got there is That's called an isosceles triangle. Put this in red for you. So it's got, what two properties has it got? Well, it's an isosceles triangle. And the two things which make it an isosceles triangle are, one, it's got two equal sides. Again, all these are in your notes, so you must use your notes. Go onto MathsWatch and search for these areas, it'll pick them up for you. Okay, videos on it. And it's got two equal angles, which I've highlighted in red there. It's actually got, because of that, it's got a line of symmetry. So if you fold that half over, that matches that, because that's what line of symmetry does, so the two angles match, so it's got a line of symmetry down the middle. And then the other one speaks for itself, try and draw it the best I can, is when you've got dashes on all three sides, that means all three sides are equal, so it's called an equilateral triangle. In this case, all the sides are equal, so therefore all the angles are equal. I'll put them in red as well, so all those are the same. Now a question which sometimes come up in the exam, if you've got an equilateral triangle, which is equal to all the angles, well, we know all the angles in a triangle make 180, and because things are equal, when we do things which are equal, okay, implies, means what to do. It means you divide, share out. You share out things are equal. If 5 people won the lottery and you share it equally, you divide by 5. In this case, you divide by 3 because you've got 3 equal angles, and that would mean each angle would be 60 degrees. That's special only for an equilateral triangle, yeah? Okay, on that one. So there's your 3 triangles there, if you just look at those. Okay, let's just take that off. I'll keep the polygon for you, the objective at the top there, the main key is polygons. Right, let's look at now all the quadrilaterals. Alright, the most common quadrilateral is a four-sided shape when all the sides are equal. All the angles inside, we know that symbol means right angle, so that means 2 lines are crossing at right angles. You had it on my MathsWatch homework, which means they are perpendicular. Okay, and that makes 90 degrees there. Okay, lines which cross at right angles are, I have to move that out of the way now there, are called, big word here, spelling, called perpendicular lines. So that, they're perpendicular, those 2 line sides are perpendicular, there, you go there, okay? What's it got? Well, it's got 4 equal sides, it's got 4 right angles, opposite sides are parallel, it's obviously a square. Another word which often comes up is the fancy word means adjacent. Now adjacent means next to. So for example, that side and that side are next to each other, that side and that side are next to each other. Opposite means what it is, they're opposite each other, they're opposite there, okay? And obviously another word coming into that is lines which never meet, like the train track, are called parallel lines. Let's underline that one. Should underline these key points. Called parallel lines. Underline that, put that in blue for you. And there's the key word perpendicular. Okay? So if I label that triangle A, B, C, D, we know that the side AB is opposite to DC, they're equal in length. BC is opposite AD, they're equal in length, they're parallel because they never meet, they're parallel, that's another set of parallel lines. Okay? AD and AB, these 2 lines are next to each other, so they are adjacent, they're also crossing at 90 degrees, so they are perpendicular. From this corner here, you can go on different corners, can't you? That DC and BC, these 2 lines here are next to each other. They're also perpendicular, so they're right angles. And you can see the redeeming fact of a square. Now, if you squash a square to the side, the fancy word is shear, by the way, but I use that, you get a rhombus. So that's how you learn the word rhombus. So again, all the sides are equal, all right? And another thing I should have gone back to, going in real detail here, we did this in an investigation to do with polygons to find the angles in any polygon. If you go corner to corner, these are called diagonals, yeah? And with a square, they all cross at right angles in the middle. That's quite good a little bit now. Same property exists for the rhombus as well, because it's got the redeeming facts of a square. It's just a squash square. You get that. But the only difference now, it does all the things there. All the sides are equal. Opposite sides are equal. Yeah, but they're not at right angles in the corners. That angle is opposite that. That angle is opposite that, but they're different. So there's no right angles, and that's what makes it. It has all the properties of a square, but that means it's a rhombus. Yeah, it's a squash square. So I've got squashed square, but don't call that in the exam. You have to use the right word, which is rhombus. Yeah. Okay. Now, if I remove those off there, you can see all those there. If I take that away there, let's get rid of all that now. I'll just leave my polygon there. Let's look at now a special case of a square. If you stretch the square to the side, yeah, drag it out. It's like a stretch. You get a rectangle. So again, like a square, a rectangle has 90 degrees in each corner. They're perpendicular, all the things is, but this time those sides are equal, opposite to each other, but these are different. They're opposite each other, but they're not the same length. So we put two dashes to say they're a different set of equal sides. Yeah, so we can distinguish between those two sides being equal. Yeah, and that's the difference between not making that a rectangle. Now, when we got the square and we squashed it to the side, we got a rhombus. Well, if you squash that to the side, you get what we call a special case of the rhombus, which is a parallelogram. And there it is, again, the similar properties here. Oh, by the way, as well, on a rectangle, unlike a square and a rhombus, the diagonals in the middle corners do not cross at right angles. That is definitely not a right angle, nor is that angle there. They're opposite each other. Them two are opposite each other, equal, they're opposite each other. But they're not the same there, yeah? So what do you get on a parallelogram? Well, opposite sides are equal. I tend to use arrows here now, okay? I could have used it on here. When you see that symbol, that means arrow means parallel sides. I could put the dash on as well to say, we don't tend to do that, but they're equal. They're not only parallel, but they're equal as well. To explain that's a different set of direction going in a different direction, another set of parallel lines going like they're never going to meet. We put two arrows on it to say it's a different set of parallel lines, and again, like the double dashes, don't tend to put both on there. They're also equal, but not the same as the other two. So different set of parallel lines, different set of lengths, but opposite each other. They're parallel, different set of lengths opposite each other. And you get a parallelogram, yeah? Again, notice with this, when you squash it to the side, the angles, like the rhombus, are not the same. They're equal each other. Those two are equal each other there as well, on there. Okay, so I'll just colour that on here. There it is. They would match up. And if I put this in blue, they would actually match up. I wouldn't worry too much about those there, but we've got those there. You can see they're matching up there. And that's, let's put the name on, parallelogram. Notice the spelling, 1R, double L for parallel. So we've got the key word, the gram at the end, parallelogram. So we looked at there, they're connected. All right, the other two quadrilaterals are, let's do one into turn. Let's go to the thing that you fly in the sky. I don't know if you do it so much nowadays. We've got this sort of, often called like a diamond shape. People use this, I think. Well, they tend to call the rhombus the diamond shape. Don't use that, it's rhombus, yeah? This has got sides next to each other, again, next to each other equal, and this is a different set of equal sides next to each other. It's a kite. It's got a line of symmetry right down the middle. Think of a kite how it's built. I'm joining in the actual diagonals here, and these are wooden frames which make the kite. And again, these cross at right angles in the middle, so the diagonals cross in the middle there, and you've got a kite. Okay, it cannot be a rhombus because they're not all the same length there. So it's a kite, and because it's got a line of symmetry that way, that angle there would match that angle because the fold it over would match that. Again, added property I'm throwing in there. So you can see that there. Okay, so that's your kite. Now the one which people often get mixed up, old roofs used to look like this from the side. You've got again a quadrilateral, because I'm looking at all the different types of quadrilateral. It's got a pair of parallel sides. It's got one pair meaning two. And it's only got one pair of parallel sides. It's called a trapezium. That's trapezium. And you've got that there. Okay, and there. Now, sometimes you can have those two sides equal each other. That's a rare case, but when they are, it's called an isosceles trapezium. Where did I get the word isosceles from? From a triangle, two sides equal. So if you use the word isosceles implying two sides equal, isosceles trapezium. We generally just call them trapezium because all the lengths are different. Yes, it should be. Because the key fact for a trapezium, it's got a pair of parallel sides. Okay, and yes, it's got diagonals which go corner to corner, like that, but there's no pattern with those across at different angles there. Alright, that covers all the quadrilaterals. We've done all the polygons, so where do we go now from that? We've done all that, mentioned regular. Right, something which you've done fantastic in the lessons with me. What do the angles, what's the sum of the angles inside any polygon? Okay? In other words, what do they all add up to inside, called interior angles, yeah? Okay? So, we'll swap my pen in a minute. So, what do we do? Well, I had an investigation going here, and we drew different shapes. So there's a triangle, then we went to any polygon, which is 4 sides, quadrilateral, any which is 5 sides, which was that. And what we did in the investigation, which was most impressive, we pick a corner, and we join to another corner, obviously through the shape. Well, this can't be, you can't join it to a corner through the shape because there's no other corner, so it is what it is, one triangle. Pick that corner there. So if I pick this corner here, and you can draw a diagonal across there, this corner here, I can pick a triangle there and there. And what we found out, we know that the angles in a triangle, whatever triangle it is, angles in a triangle always make 180, so that makes here 180 degrees. So that's what angles in a 3-sided shape make 180. And then in a 4-sided shape, 4 sides, we found that we've got 180 going into these corners here, and then another 180 going into these corners here. So in total, all 4 corners are covered. 2 times 180 gives you 360 degrees. And there was a pattern built in, yeah? This one can be split into 3 triangles, each giving 180 degrees. That triangle's putting angles into these corners, that's for in this corner in. And then the last triangle completes all the corners, and all 5 angles add up to 3 times 180, okay, which is 540. There's a little pattern developing, yeah? Some people remember it different ways here. So we went on to do 6, and what we found out was, if you've got a 3-sided shape, you can split it into 1 lot of 180. When you've got 4 sides, which we've just done on the board there, 3 sides, 4 sides, you've got 2 times triangles, 2 times 180. 5 sides is going to be 3 times 180. And then obviously 6 sides, no need to draw a diagram, you can see the pattern going 1, 2, 3. It's going to be split into 4 triangles, 4 times 180. Okay? What did we find in the pattern there? Well, look at the 2 numbers here. 3 sides going to 1 lot of triangle. 4 sides the shape's got, but it's got split into 2 triangles. 5 sides, but it's been split into 3 triangles, 6, and so on. And you find that it's always 2 less. In other words, the number of triangles you can split it into is always 2 less than the number of sides. So knowing that, okay, that's the little rule we use. So for example, if I put on the board here and said I've got 10 sides, which is we know from the earlier work I've just done, we've called a decagon. What do you need to do? Well, you don't do 10 times 180, because if I was to draw it out, you wouldn't split into 10 triangles. We know it's always 2 less. So you 10 take away 2. And that magic 8 tells me if you were to draw a 10-sided shape, which you don't need to because mathematicians use rules to speed things up, it means you can split it into 8 triangles, each giving you 180 degrees, and you do 8 times 180 there, okay, which gives you, from that, if I can work the maths out there, okay, I'll do what you do here, I'll do a little sum, okay, I'll do it here, 8 8s is 64, so 180 is 8, add the 6, gives you 14. But we've got to add the naught on there, so it's 1,440 degrees, and that's what you would do. And that's the little rule which tells me what all the angles in, it gets bigger and bigger. Okay, knowing that, let's just remove all that from there. So to summarise that quickly, okay, we find that, how do we find the angles in a polygon, yeah? In a polygon, you count the sides, subtract 2. Why subtract 2? Because that little subtract 2 tells me from the numbers size how many triangles you split it on it, and then multiply by 180. So if you've got, again I'll say 10 sides, take off 2, means you can split into 8 triangles from one corner. 8 times 180, as I've just demonstrated there, gives you that angle 1,440 degrees. Okay, so where does that go in terms of questions? Alright, well, I could have, for example, I could draw on the board here. I'm not trying to attempt to draw an hexagon, not the best, but I'll try my best. It's not drawn to scale, so this is not to scale. Let's try it again, that's not terribly well. Obviously I'm trying to make it regular, by the way, here. So let's say I've got that there, put that on there, put that on there. Let's see, get a bit better. It's not bad. Now, if I have a toe, it's regular. Yeah, or we have dashes on it. Now that's called a regular hexagon. Now you could pick a corner and split it into triangles if you want to go that way. If you can't remember the rule, and it will work for going triangles. But the rule is, because we've got 6 sides, we do 6 take away 2, which means you can split it from one corner into 4 triangles. Demonstrate. 1, whoops, again. Okay, you don't need to do this bit because the formula does it for you. Okay, if you were to split it, there are 1 corner diagonals there, another one there, 1, 2, 3, 4, 4 times 180. Tells me what all those 6 angles add up to. 4 times 180, okay, 720 degrees, yeah. Okay, just check my maths there. Always check your work. 8 4 is 32, 1 4 is 4, add 3, 72, put the 0 back on the end, 720. Now, because it's regular, normally what you do have is you're given 5 of the angles. If it wasn't regular, it was irregular, you get 5 of the angles, yeah, and then add them up and then take them from 720, that gives you the missing one. But because this is a special type, i.e. all angles are the same, then you share it out. So each angle inside, each angle would be equal to 720 divided by 6, because there's 6 sides, 6 equal angles in the middle. If you're using a calculator, you get that, or you could use the bus stop method if you weren't using the calculator. 6 into 7 go 1, remainder 1, 6 into 12 go 2, put 6 into nothing go 0, 120 degrees, each one would be 120, that makes sense. 123, 6 times 120 gives you back 720, so you can always check your answer by saying if each angle is 120 and you've got 6 of them, check it back, that will give you back your total before we start. We know they always add up to 720, okay, on that one. And you can do lots of, other things from that. For example, I might have this is not meant to be symmetrical, so that I'm not implying that's regular. It might look like it's regular there, so I might have one of those thrown in, I might have 102 there, I might have a 91 there. Let's say that's my missing angle. Let's say we've got, 88 there, yeah? And what you need to do is find the missing angle. Well, first of all, because it's got 5 sides, we need to know what all the angles are. You can split it from a corner if you want, but the rule I've given you is get 5, take away 2. That means you can split it into 3 triangles. 3 times 180 gives you, from that, let's do it 18 times 3. You can use a calculator if you add one, 24. 1 3 is 3, 54, add the 0 back on, 540. And what you do, you add up the angles you know, obviously show you working out. You've got a calculator. I'm not using my calculator, I'll do it quickly here. You've got 91, remember that means 90. So you've got them, add them up. So 2 and 8, was 102, 88, 91, and the 90 there. 2 and 8 is 10, it's 11, carry the 1. 9 and 1 makes 10, 19, 27, carry the 2 there, and it gives you 371. Now that's right, so those 4 make 371. The missing one has got to add with that to make the magic total 540. So all we do is to get x, you do 540 minus 371. That will be working if you're using a calculator. I haven't got a calculator, so I'll do it quickly here. So do me counting up. 0 take away 1 you can't do, bar off there, put the 1 back on there. 10 take away 1 is 9. 3 take away 7 you can't do because it's bigger at the bottom, so bar off the 5, put the 1 back on here, leaves you 4 there. 13 take away 7 is 6, and 169 degrees there. It wasn't to scale, by the way. An exam often says not to scale, which means you can't get an angle measure and measure it. You've got to do it by mathematical calculations, knowing the rules I have given you. Okay, I think that covers about everything on that. Now, obviously, that was units. I'm obviously covering units 4 and 5 here. That's really now comprises all units 5. So the other unit, unit 4, I'm just going to look into that. So what have we got on that? Okay, well, we'll still leave the word polygon up there. We've got the word net. Now we've all heard that, I'm sure you've done it many, many times, the word net. So what is the word net? Underline that, put that in blue there. Okay, what is it? Well, it's for a 3D shape, okay? So it's a I'll just write 2D for stuff. I've already said the word dimensional. it's on the board there, so I'll not spell that again. So it's a 2D flat, you know, 2-dimensional means flat, okay, flat shape that can be folded up to make the 3D shape. That is the real definition of what a net is. Okay, so knowing that, let's do an example. So you might have to draw this accurately. So you might have some centimetre square paper where all the distances are each line is centimetre, and you might have a what we call let me do it before. Well, let's do one of the questions here. Let's say we've got a box like this. Okay, a rectangular box, but 3D. Okay, so that height is 1 centimetre. Let's say the width is 2 centimetres, and this is 4 centimetres. That's actually a cuboid because all the lengths, not all the lengths are the same. The length, the width, and the height are different. Yes, it's a cuboid. If they're all the same, it would be called a cube. Now, if I was to draw the net, okay, a little exam tip for you. Okay, checking my pens are not doing so well here. Exam tip, it's better. Okay, right. When drawing a net, start from the base, unless they tell you otherwise. Yeah, so start from the base, and you'll never go usually wrong from that. So the base is 4 by 2 in terms of its dimensions. So you draw this accurately on square paper. So 4 centimetres, use a ruler, pencil. You've got square grid, so the distance between each square, the length of each square on your square paper is a centimetre. That's 2, and that's now the base of it. So I'm going to line like that there, called the base. And then what you've got is, can you see all these? I'll just put this in the back here. Put this in red actually. On the back here, you drop these down here, and you can see the back of the shape now. Okay, that's the proper 3D. Now, each of these, which I'm going to highlight in blue, this is the heights of the cuboid, and each of those drops down, so it's folding down, it's folding out to make a flat shape, which is the net, and each of these drops down by a centimetre. So what actually happens is, from the corners here, you drop a centimetre that way, centimetre that way, centimetre that way, there. Corners, centimetre, 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 and there are all those are 1 centimetre in length, yeah? That then forms, basically what's happening here is that face is dropping down, this rectangular face is dropping down, this one is all 4. So you've now got the start of the net building up, okay? And because obviously that's still 4 centimetres because it's parallel to that, these are all 2 centimetres, and each one of these is 1 centimetre. That's what we've got to remember, it drops down, like little props dropping down. 1 centimetre, 1 centimetre. Now the bit missing, unless they tell you, if it hasn't got a top, then that will be the net. But it has got a top. Now the top here is identical, and a word in maths, I'll throw that in for you actually. If you ever heard the word, this is not in the exam, on the test, congruent, yeah, congruent shapes, exactly the same shape and size. Identical numbers. So if I had another one of these whiteboards and I've got another one, they will be congruent. They're exactly, they fit on top of each other exactly. Okay. So therefore, the top of this is identical to the bottom. Fancy word is congruent. So where can I place it? Well, you can either place it there. So when it folds over, it comes over here. You can place it here. So when it comes over there, you can place it here. So when that folds over, it folds over there. Or you can place it there. Okay, so there's 4 positions, don't obviously put all 4 positions. So let's say, for example, you went to the top here. All you would do, I'll put this in red, you would match that up, which is 2 centimetres there, so that would be 2 centimetres. Obviously this goes across parallel to it, and there it goes, and that would be the top, which would fold over, and that would match that. Okay, let's say you didn't, if you did it on the other side, it would be identical the other way. Well, let's say you attach it the other way around, yeah? And what you would have to do is the rectangle be the other way around. So I'll put it on the side here. Again, that's going to be the top here. I'll leave this one on now. I can put in there. There's the top. Now, when that folds over, that length's got to match that length, which is 4. So that's going to be 4. Obviously, that's parallel to that, so that's 2. And you've got the top. So you can put it in one of 4 positions. I'll leave that. And that will fold up to make that cuboid. Okay? Then you could be asked to, well, let's remove that off. That's your net work there, which you need a ruler, sharp pencil to draw that accurately. It'll be given on square paper. And then you could be asked to look at, well, before I carry on, let's look at our different types of shapes. I think this is these are called 3D shapes, yeah? We've done 2D shapes. 3D means you're creating an extra length. So you've got length, width, you create an extra length, which is height, yes? That creates the 3D effect. You've got the one I've just talked about. Let's look at the cases. They're very similar to like the square and the rectangle, yeah? Or square is like a 2D version. 2D, if you put a square into 3D, you make a cube, yeah? So you get this, that's like the spine of the shape, so keep them the same. Draw that parallel to that parallel to that parallel to there, and you can see my cube being drawn up there. If you were to put the back in here, I can get that in there, you've got that going on there, and there's your cube. So that's called a cube, like a die, okay? A die, when you play a board game or whatever, is actually a cube die. By the way, that is the correct spelling. Dice is plural, which means more than one. So I know it doesn't sound right, it's true. That die means one, dice means more than one, plural, that, yeah? If you stretch that out, you get that rectangular box. So all the lengths are equal in that, yes? All the sides are equal. If you stretch it out, so the lengths aren't equal, there's the spine of it again. So making these different lengths, okay? Or just make sure they're not all the same length, then you get a cuboid. Draw that parallel to that, okay, that parallel to that, and you've got the cuboid there. I'm not going to put the back in there, which I did before. That is a cuboid. So that's another type of 3D shape, yeah? And then you've got the shapes, which are rather special. And there's a category. Let me draw them on the board, and I'll categorise them for you in a minute, yeah? You've got the ones which point upwards, like this. Okay, and this one's got a circular base. I'll come back to that one in a minute, yeah? When they point up, they're given a name in a minute. I'll come to that. Now, I could have one which looks like it could have a base which could be square or rectangular. I'll try and make this square. There's the centre, so if we go a bit higher up there, you've got this shape. Oh, we're going to get that right. Yeah, not bad. And these are the, oops, draw that a bit better. Across there. It always goes to the top. They're 3D shapes, yeah? And they're called pyramids. All right? And the reason why they're called pyramids is because the peak at the top is what we call a vertex at the top, yeah? It's pointing right up like the Egyptian pyramids in Egypt, yeah? Pyramids go right up. And obviously the name comes from the base. So if it's a square base, it's called a square base pyramid. If it's a rectangle, it's called a rectangular base pyramid, yeah? Okay? So that's called a square based pyramid. So pyramids are the ones which go up there. Now you would call that a circular based pyramid, but it's got they've changed the name, and it's got its own special name called a cone. So you must use that word, cone, there. Alright? And then we get into these other shapes. We've got, some of your pencil cases look like this. You've got, there, let's imagine your pencil case, that's the height of your pencil case, but this time this front bit, this like tunnel, which is the same by the way at the bottom, is a circle. Okay, so there's your 3D effect there. That's called a cylinder. Okay, and then you could have various other things like this. You could have chocolate. I think it's nugget, isn't it? On this one, Toblerone packet. Yeah, and what it does, it looks something like this. I'll try and draw that in. I'll try and put 3D effects on this one. So you've got a line going across the bottom there. Join that up. You've got the side going across there like that. So you've got that sort of effect, yes? And you can have all sorts of them. I've even seen chocolate bars in this sort of shape here. You've got like a trapezium at the front. So I'll get a bit of pen there. So trapezium here. There it is. And then what happens is that shape repeats right across there. So it's the same at the other end there. I'm not going to do this as well, I don't think. I'll try my best. Okay, join that up. And what I'm trying to get there, the effect of there, which is difficult, we might be able to get a bit of that in there. You're getting this effect here at the back there. And what you're noticing is they're all these, the shapes these, okay, if you were to cut from one end of it, these are rather special cases, yeah? You can see on the cube here, that face there, let's do it, I'll actually put this in blue. I'll use the blue pen for a bit. You'll see that there is the same at the back. So if you go wrong that length, the shape of the tunnel, yeah, what we call the cross section there, doesn't change, it goes the same across there. Same for this one. With a cube you can go in many directions. So this one here, this bit here, yeah, if you go to the back of it here, you'll have identical at the back of it here. Let me just put my lines in here. There we are. And you can see at the back there that the actual shape is the same at the back. So if I was to like cut like a slice along here, the tunnel, that shape would stay the same along that length. That would say. Cubes and cuboids are special because you can do it from that side or cut downwards as well. However, you can't do it with that because as you cut along here, that circle gets smaller. Okay, so it doesn't have that sort of a special property. That doesn't. Those rectangles will get smaller if you cut it up. They get smaller and smaller as it gets to the top. However, these shapes here, you can see that that circle there is the same all the way along its length. So if I cut it along here, it will be the same, and it goes all the way to the bottom. So when it's got like a tunnel going right down, it doesn't have to be from both ends, at least one end, one face, it's the same all the way along here. This one looks the same in one position. This triangle is the same right across there to the back there. I'm not drawing that terribly well, but it would be the same. And that trapezium here, like a bar of chocolate there, that would be the same at the other end here. Actually, if you cut it, it'd be the same along there. And they're all called prisms. Yeah? So a prism, all right, is another word I want to get to there, yeah? So let's just try, let's get rid of those off the board. They're special types of prisms. Let's remove that. And I'll leave those two bottom, those one at the bottom. They're all prisms, okay? Okay, so a prism is again a 3D shape. It's got 3D, yeah? Okay. Whose cross section, that's the cut, I call it the tunnel, is the same along at least one length. It doesn't have to be more than one length, but at least one length. Cubes and cuboids can be done in more directions. Yeah, okay, you can see there that circle stays the same all the way along there. Okay, that triangle stays all the way there, and you get that. Now, often the name is given to this is called the tunnel. Yeah, the blue bits are the tunnels or cross section. I call it tunnel or cross section. And because that stays the same, it's called a prism. Now, usually giving a name to the front bit, obviously we call that a cylinder, that has a special name. But this one, because it's got a triangle going the way like, it's called a triangular prism. So remember that word, triangular prism. Again, it should be in your notes with your teacher on that. Okay. Let's go back, nearly there. Okay, that's your prisms done there. Let's go back to your nets. You could be given a net and asked to describe what it represents. So I could be putting it on the board here. Now you notice how I worked before. I started from the base. Now if I draw that there, and I draw one there, you can see this is the flat version of the net. Now when that folds back up, that's your base, and these will peak at the top, and I think you can probably see there what you would get is there's the base, these will be peaking at the top here, and you get what I had before. It could be rectangular or there, square, or it could be rectangular, depends on what that is. I'm making those the same. So square, based, pyramid. So you could be asked to recognise when they fold up what 3D shape just discussed they will make. Okay? And then finally, which I know is on Unit 4, the last bit, which you'll need for this test, it could be probably calculated, but still show you workings out. There's a bit of drawing involved, so you need a ruler and a pencil. And one of the other things you will need is one of these which I'm holding up now. You might have a protractor, it's used for measuring angles. Okay, so for example, if I put on the board here, let's see if I can draw this accurately with my ruler. Okay, let that on the board here. Let's draw a line, because an angle is a movement between two lines. Let's say that's like my pivot where it turns, and let's say that turns round here. So at the moment, the two lines are on top of each other, so the angle's nothing. As it starts to move, I could go anti-clockwise, I could move my angle clockwise. I'll go this way and there, so it's turning now, it's creating a gap, an angle, and I might be, let's say, here. Okay, and obviously, there's two angles you could be measured, yeah? It could be that bit, that's where you measure it, that's the arc, which tells you where the angle. It could be this one here, all the way around. Okay, so a bit of revision just before, I'm adding a bit of notes on for you, even more of your maths being added on here. So there are three types, well, there's four types of angle actually. Okay, if you get an angle less than 90 degrees, which is estimating looks like that, that's called a acute. Right, if it's exactly 90 degrees, like that, the classic L shape, is called a right angle. Okay, let's go on to the other side of the board here. If you've got an angle between 180, so between, 90, so I'm moving up now, so I'm moving on from the pattern here, and 180, so there's your line. At the moment, if I move my ruler around here, you can see that's turning through nothing, acute, 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 acute. Now it's at right angle, now it's gone beyond 90 degrees until it straightens out here. So an angle between 90 and 180, which could look like that if I went that way around. So between 90, I'll put the symbol on the top right hand corner, that means the degrees, it's called a obtuse angle. Okay, and if you now, there's the obtuse angle there. If I now pick it up again, this time, again, let's do it again here. 0 degrees, acute, 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 right angle, going right across. This is this is obtuse, obtuse, which is between 90. And then when you get that, we call that a straight angle. So that imagine that's your pivot, and that's like half a protractor, which is 180 degrees, which is called a straight angle. If you go beyond that, okay, if you go beyond that, so now I started there, didn't I? I turned it around like that, and I go further around now, so like this. So that's my original line. Turning around, and right round like that, and go right across. You've gone past 180 now, so between 180 degrees and 360, and 360 degrees is called a reflex angle. There's the word reflex. Sorry, my pen's going a bit there. I have to finish the thing off in blue, I think. Okay, then finally, okay, I'm going to rub all these off in a minute because I need to do my measure, drawing that measure in that angle. And then finally, if you, okay, go all the way around, so there's your starting point, acute, acute, right angle now, obtuse, 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 flat, so it's flat, straight angle. Now it's turning all the way around here. This is all reflex now because the angle's gone all the way around, turning further, and then back to itself as a full turn. And when you get a full turn, okay, like this, so you started there, you go all the way around, back round. That's like 2 180s, 2 halves make a whole one, and 2 times 180 means you get 360 degrees, which is a full turn. Angles round a point are up to 360 degrees. So there's just thrown a bit of revision on that one here. Let's get rid of those and let's go back to the 2 things here. You now need to know how to use an angle measurer. Okay, so let's quickly do this. So the arc will tell you which way. So if that's there, that means you're measuring from that line to that line or that way around. Doesn't matter which line you start at. What you do is you'll notice you've got a protractor like this. You need to put the centre of the protractor on where the 2 lines cross. You've got 2 scales. One will go 0, 10, 20, and one will go wrong way around, minus 180 to 170. You need to go the one obviously start at 0 when you measure. So it depends which way you measure around. It could be the inside scale, which is going 0, 10, 20, or the outside scale, which is going 0, 10. So if I now place it here, on here, I'll use my blue pen here. So I'll use the red pen quickly. On here, I place it on here. I'm going to measure, I'm setting this bit at 0, you can see, I don't know if you can see there, but the scale's going 0, 10, 20. So you measure around 10, 20, 30, 40, multiple 50. There's 60, which is slightly over. Halfway in the middle there is 55. So 55, each dash is 1, so that's 55 there, 56, 57, it looks about 58 degrees that does, yeah? Now in the exam, as a marker, because we've all got angle measures, not easy to use, you're allowed to be plus or minus 2 degrees out. So you're allowed, so the official hand side measure there is that. You're allowed to sway back by 2, so 56 degrees. 2 in front of it, which is 60. So if you've got any answer from 56 to 60 will be allowed in the exam. You're allowed to be 2 degrees out. And also measuring, by the way, on a ruler, you're allowed to be, I think it's 1 millimeter, 2 millimeters, so 1 millimeter out. So remember on a ruler it's 1 millimeter, 10 millimeters to centimeters. So when you're measuring lines, which we're not doing here, we're measuring angles, you're allowed to be, you've got to be within 1 millimeter of the actual measurement, yeah? And that's how you measure that. Now, you could be asked, and obviously I could have done, just to prove to you as well, and remove that there, just to prove to you, I could have gone the other way around. It's easy to start from there, but if I now put my protractor. I don't know why I would do this. And start at the top here. I'm starting 0 on the line here now. The scale's gone the way it's on the outside now. And again, look where you're moving with the arc. You're going that way. So put that in the centre. Outside there, look for the scale which goes 0 to 10. You're moving from there to there. So you're moving this way around, that way down. So 10, 20, 30, 40, same idea, 50. There's 60, 55, 56, 57, 58. So you could do it the other way around, but it's easy to go from, I think, the bottom bit and move upwards that way, anti-clockwise. And then you could be asked to draw an angle. So let's say you're asked to draw, let's say, I don't know, let's say you're asked to draw 142 degrees. Okay, you've got to draw it now. So the first thing you need to do there is, first of all, draw a baseline. You need to have a line. It's movement between two lines. So you draw a line, doesn't matter how long, sometimes they give you there. So I'll draw myself a line, a fairly long line, but I've got to be careful because I've got to leave myself enough room to depend which way I'm going to move it. Now I'm going to choose to pivot it there. I could turn it about that side, and then obviously I'm turning here. I could turn that way around there. I'm choosing to go on the left hand side. You could go right hand side. And what you do again, you're going to do 142. So what you do on there, put it on the end of the line here, okay? And obviously, you've got to make sure you're moving off the line here. So your movement has got to be on the line. It's got to be on the line. So when I place that on there, this bit is no good here because that's not part of the line. So when you put the centre of the angle measure on there, line it up, bang on 0. Make sure it's actually on the line. The scalar is actually 0, 10 on the inside because I'm going this way around. And you go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, there's 140, and then 2 dashes after it, there's 140, 2 more dashes, put a little dash there, and what you've just done, you've just moved that from that little pivot. Actually, I need a better, imagine imagine me turn there. What you've done, you've turned it round like that, so there's the angle opening up, it's gone right round to this bit here, turn round. You get your ruler, which I'm going to do. Ruler and pencil sharp, make sure it's accurate, sharp pencil. Join that up, don't just go to the dot, go past it. So you've got a nice long line, and then because you moved that, you moved it round that way. Label it 142, and you can see that's a reflex, sorry, not reflex, an obtuse angle. And I think that concludes, that's quite a lot you have to do. It took me a good hour to do all that. I hope that's been useful for you. And that should give you a good chance using your book notes. Using my video here, going on to Mass Watch and searching things like measuring angles, drawing angles, polygons, you have videos on there, you'll find all the stuff on there, regular shapes, triangles, special triangles, it'll all be on there if you search, put the right things in there. Well, your book notes should have all this on it. There's revision clubs on a Monday B, once every 2 weeks, so on a Monday B, and that's in D15, so if you want to go to that at dinner time, I'll always come and ask myself, or any of you teachers for help, assistance, but I hope that'll be useful. Okay, thank you very much. Just doing a video. Ooh, don't do that to me. Oh, go in. Oh, so this is off when you're out here. I've sent an hour video in here. How's this not coming off on me? Oh, you're laughing at me. I'll just try not mess this up now. Well, no, I'm supposed to. Is that stop?
No,
No, what about that there?
Click
You sure? I'm not going to lose it because I've clicked.